Welcome to this kind of an intro video on probability in compound events. So for this video, we are going to focus on three types of compound events. We've got the OR event and then the complement, which sometimes we refer to as like not. Like, what is the probability I'm not going to throw a 3 in a six-sided die kind of a thing. So these are the three we're going to go jump into, and let's just jump right in. So we're going to start with an OR problem, and we've got ourselves 11 cards that have numbers on them, 0 through 10. And you can see, hopefully, the colors come out nicely with the contrast. But we've got colored numbers and colored backgrounds. So the first thing, what is the probability of choosing a purple number or a number less than 3? Now, just to kind of give you a visual, we are talking about two things. We're talking about a purple number and a number less than 3. So this circle is all about purple, this circle is all about less than 3, and this middle piece is what shares. Now you'll notice this is a purple number. 0 is less than 3, so 0 would go in here. Number less than 3, then we would have 1 and 2. They are not purple, so they would go over here. So if you think about it, based off of this, we have 3 numbers, 0, 1, and 2, that are either purple or less than 3. Now, 0 happens to be purple and less than 3, but that's okay. So I have 3 numbers total that satisfy this OR problem out of 11 total numbers. So the probability would be 3 out of 11. In a high school math class, 6 students were basketball players, 4 students were wrestlers, 5 were cheerleaders, and 7 were in the pep band. No student is in both things. What is the probability a student chosen at random is a basketball player or in the pep band? Okay, so let's think this through. If we're talking about basketball player and pep band, so I have 6 basketball players, I have 7 pep band. So 13 are basketball or pep band. Well, how many do we have total? 6 plus 4 plus 5 plus 7 gives me a total of 22. So the probability of picking a basketball player or a pep band would be 13 out of 22. All right, let's jump into the world of and. Now, you'll notice that with or, it was okay that they were completely different, right? This or that. When we're talking about and, it has to satisfy both criteria. So the probability of choosing a card that has a red number and is greater than 8. So when I think, okay, let's again go with this piece here. We're talking about red and greater than 8. Okay, so my red numbers, I have 4. Well, that's not greater than 8, so that goes over here. 10, that is greater than 8, so that goes here. And then other numbers that are greater than 8 would be 9, but it is not red, so it'll go here. Now, because I want and, the and piece is that middle spot that satisfies both criteria. There is only one number in that shared space. So the probability of choosing a number that is red and greater than 8 would be 1 out of 11. Now let's look at a contingency table, kind of doing the same thing. What is the probability a person chosen at random is a Democrat and a male? So we are looking at the intersection, right? And. So here's my Democrat line. Here's the male line. And if I want Democrat and male, I'm looking at where they overlap. So in this case, there are 47 people that are Democrats and males out of the total 376. And that would be my probability. So when you think of the word and with compound probabilities, we are talking about the overlap or the intersection that things are happening. Now let's use that same chart and let's do an OR problem. Probability a person is female or an independent. Okay, so I have my female line. I have my independent line. Now, if you think about this, you'll notice that we have circled the female independent twice. So we want female, 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 independent, right? That's kind of the L that we're looking at. So if I add those 4 values together, I'm trying to find my spot. I have 271 out of the total of 376. Okay, and we're going to get to some other videos where we talk more about the algebra behind this. But now let's get to the complement. So the complement is simple, right? Again, means not. So what is the probability of a number that is not on an orange background? Well, if you think about this, the number 2 is the only number here on an orange background. So the probability of orange background is 1 out of 11. So that means the probability of not orange background is everything else. So 1 is all of it, right? 11 out of 11. Actually, let me just go ahead and type it like that. Everything, the whole piece is 11 out of 11. Let's take away the 1 that has an orange background, and therefore the probability of not orange would be 10 out of 11, which makes sense, right? Because the other 10 all do not have an orange background. Let's do one more. What is the probability of choosing a person at random who is not an independent? Okay, so here's my independent line. I know that the probability of independent is 181 out of 376. So the probability of not independent is the whole thing, 376 over 376 minus the independents, right? Because it's everybody else. And therefore, the probability of not independent is 195 over 376. A little bit of a long video, but we had 3 distinct topics to talk about. Hope that those made sense. Thanks, y'all.